Hello everyone. This particular lecture is about data size measurement and it is with respect to O levels. All right, if you are AS level students in the current syllabus, terminologies are changed and they are as per IEC instead of SI units. So basically, if you are AS student, please do not listen to this particular lecture. Rather, look for the lecture which is for AS in particular. So this particular lecture is about how to quantify the data that is being either transferred or stored. When it is stored, it might be in the RAM. When it is stored, it might be over the hard disk. Not just that, it is also about how to measure the size of physical hardware memories. So let's discuss about it. So memory sizing and measurement with respect to O levels. So whenever we have got binary data, basically we are looking at the data from two aspects. One, the data is being stored or it is already stored in hard disk or maybe SSD or RAM. Whereas secondly, we will look at the binary data which is being transferred, either it is being uploaded or downloaded. So when the data is on the move, whether Wi-Fi, whether through Bluetooth, maybe internet, it is being uploaded and downloaded. When the data is being uploaded or downloaded, basically we look at the data in terms of bits. But when the data is stored and it is in stationary position, whether it is in the RAM or the hard disk or whatever, so we actually look at it in terms of bytes. So quantifying data when it is stored, it is being stored, or the storage devices themselves is requiring you to have quantify it in terms of bytes. Whereas when the data is being transferred, it is being downloaded, uploaded, whatever, it is being seen in terms of bits. So let's look at this chart. Whatever, when the data is being stored or it is being moved, the smallest unit of binary data is bit. Bit stands for binary digit. All right. So bit is a single unit of a binary number system. Bit means binary digit. So it might be a 0 or 1. All right. A couple of times in past papers, a combination of 4 bits was also discussed, and it is called nibble. All right, it is not part of the syllabus, but sometimes in the past papers, it was referred as nibble. So 4 bits. 4 bits is equal to 1 nibble. And similarly, 8 bits combinedly form 1 byte. This is something in particular which you have to keep in mind, and it is rather important. Now, let's first discuss whole terminologies with related to bytes and for the data which is being stored. So 1 bit is the basic unit, which is either 0 or 1. 8 bits combinedly form a byte. And then 2 to power 10 means 1024 bytes combinedly form kilobyte, which is also called KB. And remember one thing, whenever we are talking about storages, it is not established, but it is understood, untold terms that we will be using capital cases. So whenever we are referring to byte, we are using big B. Similarly, whenever we are referring to kilobytes and all, we are using K and B all in caps. So 1024 bytes is equal to 1 kilobyte. 1024 kilobytes is equal to 1 megabyte. 1024 megabytes equal to 1 gigabyte. 1024 gigabytes equal to 1 terabyte, and 1024 terabytes equal to 1 petabyte. So 1024 bytes is basically 2 to power 10. Similarly, 1024 kilobytes is equal to 2 to power 20. And then we have got 2 to power 30 as 1 gigabyte, which is 1024 MB. And then we have got 1024 GB, which is 2 to power 40. Remember one thing, there are different schools of thought. And actually, I was referring to it when I was talking about AS level. The system that we use in our general life is SI system, International Systems of Units. There, the closest thing is mass. So in mass, when we measure quantities, we measure with like 1,000 grams equal to 1 kilogram and all, and that we have brought into the computer science. But thing is that that particular SI system is based on denary number system, decimal number system, or base 10 number system, whereas the binary number system is based on binary or base 2 number system. So for base 2, it is 2 to power 10, 2 to power 20, and 2 to power 30, whereas in base 10, it is 10 to power. So basically, in any case, please abide by using 1,000 units. Rather, we will be using 1,024 units. So no matter who says, no matter where have you seen, sometimes in past paper, it was being neglected, it was being overlooked, and it was allowed to use 1,000 factors. Since calculators are not allowed, so people find it easy to divide numbers by 1,000 rather than 1,024. But remain assured that if you would do this time, we'll lose marks. So 1,024 is the factor. All right. So when we turn bit into byte, we use 8 bits. When we turn bytes into kilobytes, we use 1,024, and onwards we use 1,024. Now look at the transmission side where the data is not being held up, rather it is being transferred, whether it is being uploaded, downloaded, or loaded, or whatever. So in those terms, we will only be talking about bits. All right, so 1 bit is the smallest unit, and then we skip nibble or byte because everything is in bits. So from bits, we will directly enter kilobits. Kilobits is 1,024 bits, and then megabits, which is 1,024 kilobits, and then gigabits, which is 1,024 megabits, and this goes on. If you could remember, the speed of internet at your home might be 4 Mbps. Whenever we say that speed of data transmission at home is 4 Mbps, speed of internet is 4 Mbps, or the bandwidth at home is 4 Mbps. This Mbps means megabits per second. So whenever data is on the move, it is bits. If I say that I've got a file which is of 2 GB, or I have taken a picture of 25 MB. So whenever I'm referring to a file or a picture, they are stored data. So in that case, GB is gigabytes and MB is megabytes. But if I say that I've got 10 Mbps connection at home, internet connection at home, in that case, I am definitely referring to megabits per second. So when the data is on the move, it is bits. When the data is being stored, whether in the RAM or the hard disk or maybe SSD or whatever, data is always counted in bytes. So one thing that you have to remember, and that is the most important thing, is that 8 bits make a byte. So this is 1 to 8 ratio. Similarly, if we would have 1 kilobyte, we can convert it to kilobits by simply multiplying it with 8. As 1 byte has 8 bits, 1 kilobyte would have 8 kilobits. 1 megabyte will have 8 megabits. 1 gigabyte will have 8 gigabits, and this goes on. So this 1 to 8 ratio remains there. Second thing that you have to remember is when we are moving from smaller unit to a higher one, a bigger one, from bit to mega, bit to giga, kilo to mega, kilo to giga, mega to tera, we are always dividing. We are using division. So when you are transferring the unit from bits to byte, you will be dividing it by 8. And if you are transferring byte to kilobyte, you will be dividing it by 1,024. And similarly, we will keep using 1,024 factor for further division. So from bit to byte, you use 8, and onwards we use 1024. And similarly, if you are coming up from a bigger unit to the smaller one, for example, you want to check that 2 gigabytes are how many kilobytes. In that case, you will be multiplying. So I have shown this with these arrows. So if you're coming down from a smaller unit to a bigger one, you will be dividing. And if you are coming up from a bigger unit to a smaller one, you will be multiplying. So what sort of questions will be there? The most common question is that if you have got certain MB file and certain MB connection, what will be the time for the transfer of file? So let's say our file size is 1 MB and speed per second is 1 MB. So in both of the cases, I have used 1 MB, but over here, when I am referring to the file, it is simply 1 megabyte. And when I'm referring to the speed of the data transfer, I am referring to megabits. So how will we find time? Time will be file size divided by the speed of the data transfer, and the result will be in seconds. Why in seconds? Because the speed of the data transfer is always defined in terms of second, in the number of seconds. So if I say I have got a connection of 10 Mbps, it means that 10 megabits per second, and that is why the result will always be in seconds. So let's say if I have got a file of 1 MB, it means that I will have to first convert this byte into bits so that I could divide. So since the divisor is in megabits, so you have to have dividend in megabits as well. All right. So you have to equal the unit. Otherwise, different units cannot divide each other because they are not equal in nature. They quantify in different terms. So if you have got 1 MB file, you will have to multiply it by 8. Why with 8? I told you that this ratio of 1 to 8 remains there. What does that mean? 1 byte has 8 bits. So 1 megabyte would have 8 megabits. So all you have to do is to convert from megabyte to megabits. You would have to multiply it by 8. So 1 MB file is 1 into 8 megabits. It will become 8 megabits, and we have got speed of 1 megabits per second. And when we divide 8 by 1, we have got 8 seconds. It means that a file of 1 megabyte will get transferred at the speed of 1 megabits in 8 seconds. Similarly, over here, we have got a file of 10 MB and the speed of 2 MB. And as per our understanding, this 10 MB is basically 10 megabytes, and this 2 MB is actually 2 megabits per second. So 10 megabytes divided by 2 megabits, we would have to first make these two units equal, means byte, either byte over byte or bits over bits. So if we go from megabit to megabyte, actually the answer will be in fractions. So without calculator in exam, it will become tough. So it is rather easy that we multiply this 10 by 8 to have number of megabits so that we could divide it easily. So when we multiply 10 by 8, we would have 80 megabits, and we have got the speed of 2 megabits. It means a file of 10 megabytes, when it gets transferred at the speed of 2 megabits per second, we have what? 40 seconds time. So we require 40-second time to transfer 10 megabytes file over a connection of, over a bandwidth of, over the speed of 2 megabits per second. Now, this time I go further up, and now I have got a file of 2 GB and the speed is of 20 megabits. So now we will have to first convert from gigabytes to megabytes, and then from megabytes, we will have to convert it to megabits. All right. Since the speed per second is in megabits, we will have to bring down this factor. Earlier, we had just the difference of byte and bits, and this mega factor was the same. Now, over here in this particular question, the file size is in gigabytes, and speed is in megabits. So we would have to first convert from giga to mega and then from megabytes to megabits. And then we will be able to equate both the file size in megabits as well as the speed. All right. So how we will go from gigabyte to megabyte? As I said earlier, that we will be, because we are going from giga to mega, we will be multiplying this gigabyte with 1024 to have result in megabytes. And then from megabytes to megabits, we will actually be multiplying by 8. So 2 gigabytes divided by 20 megabits per second. First, we will multiply this 2 by 1024 to have 2048 megabytes divided by 20 MB. Now the mega factor is equated. Now we have to convert this byte into bits. So for that, we will be multiplying 2048 by 8. That will give us 16,348 megabits. And now megabits for the file size and megabits for the speed are now equal. So we will be simply dividing and it will give us 819.2 seconds. And if we divide those seconds by 60, we will have 13.65 minutes. Now, let's drag this further. Let's say you have got a file of 2 GB and you have a connection of 512 kilobits per second. As we know that 1 MB is basically 1024 kilobits. So 512 can be considered as 0.5 MB as well. So now I have taken both things into consideration and I have solved the question from both aspects, where I have brought down gigabyte to kilobits and where I have, and in second form, I have taken this gigabyte to megabits and as well as 512 to megabits as well. And then I have divided. Both are there. It's up to you how you do that. It's your own perception, your own feel of easiness, the comfortability that you get in absence of the calculator. Now, this is 2 GB file. So what comes to mind is first to convert this gigabyte into kilobits. So for that, I would have to first divide those both, and then gigabytes, I would have to first convert this gigabyte to megabyte. So how would I do that? I will be converting gigabyte to megabyte. So I will be multiplying gigabyte with 1024. That will give us 2048 megabyte. And then I will be multiplying it by 1024 again to have the answer in kilobytes. So 2048 multiplied by 1024 kilobyte gives us this 2097152 kilobytes. Now the factor of kilo is matched up. Now we have to convert this byte into bits. So 2097152 multiplied by 8 will give us 16777 kilobits. Now the factor is same. So we can easily divide now. So 16777 divided by 512 will give us 32,768 seconds, which is 546.13 minutes. This is one of the way which is rather lengthy. So if we think that we bring this gigabyte to megabits and also bring this kilobits to megabits, that will actually reduce our calculations, but the answer will remain the same. So let's see. So 2 gigabytes and 512 KB. So let's bring this gigabyte to megabyte and this KB to MB. All right. So KB to MB means division and gigabytes to megabyte means multiplication. So we will multiply this 2 by 1024 and we will divide this 512 by 1024. In both of the cases, the result would be in mega. So this becomes 2048 megabytes and the speed will become 0.5 MB. All right. Now we have to convert this byte to bits. So we will be multiplying 2048 by 8. In that case, we will have 16,384 megabits and the speed has already been brought down to 0.5 MB. And if you do the math, you will get the same result as you would have over here, 32,768 seconds, which if you divide by 60 will become 546.13 minutes. So get used to with it. You should be familiar with this scheme, and this is what is understood for your syllabus throughout in paper 1 and paper 2. So if you have any question, do ask those questions in comments below or in your respective WhatsApp group. I'll try